Host speaking. What if I told you a star may have passed by our solar system, coming closer to Earth than NASA's Voyager probes? Well, that's exactly what recent studies suggest. In today's episode, we'll dive into the fascinating discovery of a star that may have ventured closer to us than ever before. Stick around to find out what this means for our understanding of space, the potential dangers, and the incredible insights we can gain from this cosmic visitor. Let's jump right in. Scientists have recently discovered evidence of a star that passed within our cosmic neighborhood a lot closer than many of us imagined. It seems this star might have come closer to Earth than even the Voyager probes, which are currently the farthest human-made objects from our planet. This discovery comes from advanced astronomical observations and computer simulations that suggest the star passed us by just tens of thousands of years ago. Although it didn't crash into the solar system, its gravitational influence may have had a lasting impact on objects in the Oort cloud, a vast region filled with icy debris orbiting the Sun. This proximity is a rare event and opens new windows into understanding stellar movements. NASA's Voyager 1 and Voyager 2 have been on incredible journeys for over 4 decades, exploring the outer planets and now venturing into interstellar space. Voyager 1 is currently about 14 billion miles away, while Voyager 2 is trailing not far behind. These probes are our farthest-reaching eyes in space, sending data back to Earth as they journey deeper into the unknown. Now imagine a star coming even closer than that distance. This revelation challenges the scale of cosmic distances we're familiar with. If this star did indeed come as close as these studies suggest, it gives us a new reference point for how interconnected our solar system is with the broader galaxy. The gravitational pull of a nearby star can have serious implications, even if it doesn't enter our solar system directly. When a star comes close, it can send shockwaves through the Oort cloud, possibly dislodging comets and asteroids. Some of these objects may be hurled inward toward the Sun, potentially threatening Earth or other planets. While the odds of such an event are incredibly low, the potential consequences could be catastrophic. Luckily, this particular star seems to have passed by without causing any harm, but it's a reminder of the fragile balance that exists in space. The discovery of such events highlights the importance of tracking stellar movements that could impact our cosmic neighborhood. The discovery of this wandering star didn't happen overnight. It involved painstaking work using data from various astronomical surveys, including Gaia, which maps out the positions of stars in the Milky Way. By comparing past and present data, scientists were able to trace the movement of this star and calculate its proximity to Earth thousands of years ago. They also used computer simulations to understand the star's trajectory and its possible effects on the solar system. These methods are crucial for predicting future close encounters with other stars and for gaining insights into the history of our galaxy. The fact that a star may have come closer to Earth than the Voyager probes suggests that our solar system is more dynamic than previously thought. This revelation opens the door for new research into the potential for future stellar visitors and their effects on our planetary neighborhood. Moreover, it shows how much we still have to learn about the movements of stars and the impact they may have on Earth. Could other stars pass close to us in the future? What kind of risks or discoveries might these events bring? Only time and further research will tell. For now, this discovery is a reminder of how vast and unpredictable our universe truly is. The star that came so close to our solar system has been identified as a small red dwarf known as Schultz's star. Discovered back in 2013, Schultz's star is located about 20 light-years away today. But research indicates that roughly 70,000 years ago, it ventured much closer, potentially passing through the outer edges of the Oort cloud. Red dwarfs like Schultz's star are relatively small and cool compared to our Sun, which is why it didn't cause major disruptions as it moved past. However, its close flyby still makes it one of the nearest stellar encounters in our planet's history, sparking immense curiosity among astronomers and space enthusiasts alike. To understand why a passing star could be significant, we need to talk about the Oort cloud. The Oort cloud is a vast spherical shell of icy objects that encircles our solar system. These objects are remnants from the formation of the solar system and are located incredibly far from the Sun, up to a light year away. The Oort cloud is home to billions, if not trillions, of comets, which can be affected by the gravitational forces of passing stars. A star passing through or near the Oort cloud can dislodge some of these comets, sending them hurtling toward the inner solar system, where they might even become visible to us on Earth. When we say a star came close to Earth, what does that really mean? In astronomical terms, close could mean millions of miles away. Scholz's star passed at a distance of about 0.8 light-years from the Sun, which translates to about 5 trillion miles. To put that in perspective, the nearest star to Earth today, Proxima Centauri, is about 4.24 light-years away. So, while Scholz's star never came anywhere near our planet in human terms, by cosmic standards, it was practically knocking on the door of our solar system. With such a close encounter, it's natural to wonder whether Scholz's star had any impact on Earth or the rest of the solar system. So far, scientists haven't found any direct evidence that the star's passage triggered any major events here on Earth. However, some researchers are studying whether the star's gravitational forces may have sent any long-period comets from the Oort cloud toward the inner solar system. If that's the case, those comets could have influenced planetary orbits or even collided with planets. But so far, no conclusive evidence has tied such events to Scholz's star. One of the most intriguing questions about this discovery is whether it's a one-time event or if more stars could pass close to our solar system in the future. The answer is definitely. Our galaxy is in constant motion, with stars orbiting the center of the Milky Way at different speeds and distances. It's entirely possible that other stars will pass near Earth in the future, and researchers are already using data from the Gaia mission to predict future stellar flybys. Some stars could pass even closer than Scholz's star, making it a top priority for scientists to keep an eye on the stars around us. Speaking of Gaia, this mission has been instrumental in mapping out the movements of stars across our galaxy. Launched by the European Space Agency, Gaia is a space observatory designed to chart a precise 3D map of more than 1 billion stars. The data it collects is helping scientists track the paths of stars like Scholz's star and predict future encounters. Gaia has revolutionized our understanding of stellar movements, providing us with the tools needed to explore how the galaxy evolves and how stars interact with one another over time. If a star passes close enough to our solar system, it could potentially cause serious disruptions. The gravitational forces from a passing star could disturb the orbits of planets or send comets and asteroids careening toward the Sun. In the worst-case scenario, such an event could lead to impacts on Earth, potentially causing widespread destruction. Thankfully, these events are incredibly rare, and most stars that pass nearby don't get close enough to cause significant damage. However, as our understanding of space continues to grow, it's clear that stellar flybys are a real part of cosmic life. Interestingly, red dwarf stars like Scholz's star are more likely to pass by our solar system than other types of stars. Red dwarfs are the most common type of star in the Milky Way, making up about 70–80% of all stars in the galaxy. They are smaller, cooler, and less luminous than stars like the Sun, which means they can go unnoticed unless they come very close. Because of their abundance and their relatively slow movements, red dwarfs are prime candidates for stellar flybys. Scholz's star is just one example of a red dwarf coming close to our solar system. The passage of Scholz's star happened tens of thousands of years ago, so humans weren't around to witness it. However, if a star were to pass close to Earth today, would we be able to see it? The answer depends on the star's size and brightness. A small, dim star like Scholz's star might not be visible to the naked eye, even at close distances. On the other hand, a brighter or larger star could create a spectacular show in the night sky. Regardless of visibility, astronomers would certainly be able to detect such an event long before it happened using telescopes and other instruments. Stars are not stationary objects. They are constantly moving through the galaxy. Our solar system itself is traveling at about 515,000 miles per hour around the center of the Milky Way. Other stars are also moving in their own orbits, and occasionally these paths bring them near one another. The movement of stars is influenced by the gravitational pull of the galaxy, as well as interactions with other stars and cosmic objects. Studying these movements helps scientists predict future close encounters, like the passage of Schulz's star. Some theories suggest that a passing star could influence Earth's climate, potentially even triggering an ice age. If a star were to send a barrage of comets or asteroids toward the inner solar system, it could lead to a series of impacts that might block out sunlight and cause global cooling. While there's no evidence that Schulz's star had such an effect, it's an interesting possibility to consider. The idea that a stellar flyby could have long-term consequences for life on Earth is a reminder of the interconnectedness of the universe and the delicate balance that allows life to thrive. While stars can pass near each other, the chances of a direct collision between two stars are incredibly low. The vast distances between stars make such an event exceedingly rare. Even if a star comes close to our solar system, the likelihood of it colliding with the Sun or another planet is slim. Instead, the gravitational effects of the star's passage are more likely to cause disturbances, such as altering the orbits of planets or dislodging objects from the Oort cloud. That said, studying these close encounters can help us understand the dynamics of stellar interactions and the potential risks they pose. Astronomers use a combination of observational data and mathematical models to calculate stellar flybys. By tracking the positions and movements of stars over time, they can predict how close a star will come to our solar system and when it will pass by. Missions like Gaia provide detailed data on the positions of stars, allowing scientists to create simulations of their movements. These models help us understand past encounters, like that of Schulz's star, as well as predict future ones. The more data we gather, the better we can anticipate and prepare for these cosmic events. One of the more speculative ideas surrounding stellar flybys is the possibility that a passing star could bring alien life with it. Some scientists have suggested that microbial life could exist on comets or asteroids, and a star passing through the Oort cloud could dislodge some of these objects and send them toward the inner solar system. If these objects were to land on Earth, they could theoretically introduce extraterrestrial life. While this idea remains highly speculative, it's an exciting possibility that sparks the imagination of astronomers and astrobiologists alike. As technology continues to advance, our ability to track and study stars will improve dramatically. Future space missions, more powerful telescopes, and better computer models will allow us to monitor the movements of stars with greater precision. We'll be able to predict stellar flybys far in advance and understand their potential effects on our solar system. In addition, improved technology will help us study stars in more detail, giving us new insights into their composition, behavior, and interactions with other celestial objects. The future of stellar tracking holds exciting possibilities for science and discovery. A fascinating aspect of stellar motion is the influence of dark matter, the mysterious substance that makes up about 27% of the universe. Although we can't directly observe dark matter, scientists believe it plays a major role in the movements of stars within galaxies. Dark matter creates additional gravitational forces that can affect how stars move, including those that might pass close to our solar system. By studying stellar flybys like that of Schulz's star, astronomers hope to gain a better understanding of how dark matter shapes the galaxy and influences the paths stars take. Schulz's star is part of a binary star system, meaning it has a companion star, a brown dwarf. Binary star systems are common in the universe, and they add complexity to stellar flybys. The gravitational interactions between the two stars in a binary system can affect their trajectories, making it harder to predict exactly how they will move through the galaxy. In Schulz's case, its companion likely influenced its path, potentially changing the distance at which it passed our solar system. Understanding binary systems is key to accurately predicting the movement of stars and their potential effects on nearby planetary systems. While our solar system has had close encounters with other stars, it's important to remember that these events are not unique to us. Stellar flybys happen throughout the galaxy, and some solar systems experience even closer encounters than we do. In some cases, stars may pass so close to planetary systems that they can disrupt the orbits of planets or even eject them entirely. Our solar system's relatively stable history suggests that we've been lucky so far, avoiding any catastrophic close calls. However, studying other solar systems helps us understand the full range of possible outcomes from stellar flybys. Speaking of other solar systems, what happens when a star passes near a solar system with exoplanets planets that orbit stars outside our own? Just like in our solar system, the gravitational influence of a passing star could affect the orbits of exoplanets or trigger the migration of moons and asteroids. This could have dramatic effects on the stability of these planetary systems. Studying how exoplanets respond to stellar flybys gives scientists more insight into how planetary systems evolve and how life might survive or be wiped out by cosmic events. While stellar flybys are often associated with potential risks, they could also bring benefits. For example, a passing star could potentially move a planet into a more favorable orbit, making it more likely to support life. If a planet were too far from its host star and frozen, a stellar flyby might alter its orbit just enough to warm it up, creating the conditions necessary for liquid water to form. Although this scenario is highly speculative, it's an interesting idea that shows how interconnected the universe is and how seemingly random events could shape the development of life. Another intriguing possibility is that stellar flybys could have influenced the history of life on Earth. If a passing star sent a barrage of comets or asteroids toward Earth, the impacts could have triggered mass extinction events or created new environmental conditions that encouraged the evolution of new species. Some researchers even speculate that a stellar flyby could have contributed to the extinction of the dinosaurs. While this remains a hypothesis, it underscores the idea that life on Earth is not just shaped by events on our planet, but by the dynamic forces of the universe around us. Skol's star is not the only star that has passed close to our solar system. In fact, scientists believe that over the history of our planet, many stars have ventured near us. By studying the trajectories of stars and their past movements, astronomers have identified several stars that may have passed close to our solar system over the last few million years. Each of these encounters potentially influenced the solar system in some way, whether by nudging comets from the Oort cloud or altering the orbits of outer planets. The more we learn about these historical flybys, the better we understand the forces that have shaped our cosmic neighborhood. Some researchers have even suggested that a close stellar flyby could influence the activity of our sun. A passing star's gravitational pull could theoretically disturb the sun's magnetic field, triggering solar flares or coronal mass ejections. These events could have significant consequences for Earth, affecting our atmosphere and technology. While this remains a speculative idea, it's an exciting avenue of research that could help us understand the potential risks posed by future stellar flybys. By monitoring stellar activity, scientists hope to predict and prepare for any effects these events might have on the Sun and our planet. If a future stellar flyby posed a significant threat to Earth, what could we do about it? Currently, there's no way to alter the trajectory of a passing star or prevent its gravitational effects on our solar system. However, by studying these events and improving our ability to predict them, scientists can help prepare us for any potential risks. Advanced warning could allow us to take protective measures, such as improving asteroid detection and deflection technologies, or developing systems to protect satellites and electrical grids from potential solar storms triggered by a flyby. While professional astronomers lead the charge in tracking stellar movements, citizen scientists can also play a role in discovering and monitoring stars. Amateur astronomers with access to high-powered telescopes can contribute to projects that track the positions of stars and monitor their behavior. Some large-scale projects like the Zooniverse initiative, allow everyday people to participate in data analysis, helping to identify new stellar objects and track their movements. This collaboration between professionals and the public expands our capacity to understand the galaxy and detect potential close encounters with stars. Rogue planets that wander through space without a star to orbit are thought to form in part because of stellar flybys. When a star passes near a planetary system, its gravitational influence can be strong enough to eject planets from their orbits, sending them drifting into the galaxy. These planets, no longer tethered to a star, are known as rogue planets. The idea that stellar flybys could create these mysterious worlds adds another layer of intrigue to the study of star movements. It also raises the question of whether rogue planets could potentially harbor life. When a star passes close to a planetary system, it can exert enough gravitational force to affect not only orbits, but also planetary atmospheres. A close flyby could disturb the atmosphere of a planet, potentially stripping it away or altering its composition. This could have serious consequences for any life forms on that planet, as a planet's atmosphere is crucial for maintaining stable temperatures and protecting life from harmful radiation. While it's unclear whether Schultz's star had this kind of impact, studying the potential effects of stellar flybys on atmospheres helps us understand how planets evolve over time. In some cases, the gravitational forces generated by a stellar flyby could trigger the formation of new stars. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.